If a row matrix is given Mn with order 1 row 2 columns, and the column matrix is given 2 rows 1 column, which is equal to a single 1 by 1 matrix with 25 element, where M is smaller than n, then M comma n is equal to. So here the multiplication of matrices Mn, a row matrix, and Mn, and here we can see that the multiplication is possible 1 by 2 and 2 by 1. The number of columns in first matrix is equal to number of rows in the second matrix. So the multiplication will be getting a single element. So which is by applying the multiplication process row with column m into m square plus n into n square with a single element, that is 1 by 1 matrix, and which is given here 25. So which implies that m square plus n square is equal to 25, because two matrices are equal here with the same order. The comparing the corresponding values, so m square plus n square is 25, and here you can see that among the options 2 square plus 3 square cannot be 25, and 3 square plus 4 square is 25, and 4 square plus 3 square is 25, but m is smaller than n, so we can write 3 square plus 4 square will give you 25, that is 9 plus 16 is equal to 25. So we can go with an option B. So option B is the answer. If A and B are two matrices of the order 3 by m and 3 by n respectively, and m is equal to n, then the order of 5 times matrix A minus 2 times matrix B. So A is a matrix with order 3 by m, and B is also the matrix with the 3 by n, and it is also given that m is equal to n, means these both orders are 3 by m and 3 by n both are same. And now it is given 5 times matrix A minus 2 times matrix B. So here 3 by m and here it is 3 by n. The matrix subtraction or addition is possible when their orders are same. So we can say that 3 by m, 3 by n both are equal here. So definitely the difference of these two matrices will be the matrix with a same order, that is 3 by m or 3 by n. So if 3 by m or 3 by n can be the answer for this question, and you can see the options here. Among the four options, 3 by m is 3 by n is the fourth option, so we can go with an option D. If determinant of matrix 2x, 5, 8 and x is equal to determinant of another matrix 6, 5, 8, 3, then find the value of x. Let us find the determinant separately. We'll get here the determinant on the left side is 2x into x minus 8 into 5, which is equal to 6 into 3 minus 8 into 5, that is 2x square minus 40 is equal to 80 minus 40, or we can write 2x square is equal to 18, or x square is equal to 18 upon 2, which is 9. So we can write x is equal to plus or minus of root 9. So x is equal to plus or minus 3. So the value of x can be taken as plus or minus 3, which is option A. Let A and B are square matrices of order 2, and determinant of A is equal to 2 and determinant of B is equal to 6. Then find 5 times of AB determinant. So A is a square matrix of order 2 and B is a square matrix of order 2, and determinant of matrix A is given. Determinant of matrix A is equal to 2 and determinant of matrix B is equal to 6. And we have the property determinant of Ka is equal to k to the power of n into determinant of A, where n is the order of the matrix A, and also we have determinant of AB is equal to det A into det B. If two matrices product is there, we can take separately det A into det B. So let us use the properties here. Determinant of 5 times of AB which is equal to, we can write 5 to the power of 2 into det of AB, because the order of the matrix is 2, so we can write 5 square 25 times, and det of AB is equal to det A into det B, which is equal to 25 into determinant of A is 2 and determinant of B is 6. So we can say this is 300. So 25 into 2, 50, 56 are 300. So 300 is the first option, which is correct. If there are two values of A which makes determinant 1 by 2 times determinant of 1 minus 2 5 2A minus 1 0 4 2A, which is equal to 86, then the sum of these values is, so let us simplify. 1 by 2 times determinant, we can write it as 1 times of 2A, that is 2A square minus of minus plus 4, and minus of minus plus 2 times of, we can write 2 into 2A, that is 4A plus 0, and again plus 5 times of, we can write 2 4s are 8 minus 0, which is equal to 86, or we can write 1 by 2 times 2A square plus 4 plus 8A plus 40 is equal to 86, or 1 by 2 into 2 taken common, A square plus 8A plus 44 means 22, which is equal to 86, or we can write A square plus 8A plus 22 minus 86 is equal to 0, or we can write A square, so here it is, sorry, 4 times, you'll get 4 here. Here it is 8, and when 2 is taken common, it is 4. So A square plus 4A, and here it comes minus 44, which is equal to, sorry, 64, which is equal to 0. And we got the quadratic equation A square plus 4A minus 64 is equal to 0, where A is where A is the root. There are two values of A, and sum of the roots of the equation, sum of the roots is minus B upon A in quadratic equation, that is AX square plus BX plus C is equal to 0. So we can write here the sum of the roots, sum of the values of A, sum of the values of A is equal to minus B by, that is minus 4 divided by coefficient of A square is 1. So minus 4 by 1. So minus 4 is the answer. So which is option C. If x power y is equal to e to the power of x minus y, then find dy by dx. Let us apply here logarithm on both the sides. So we have log x to the power y is equal to log e to the power x minus y. And by using the property log a power m is equal to m times of log a. So we can write here y times of log x is equal to x minus y times of log e. And also we know that log e value is 1 since the base is also e. So here we can write log e to the base is 1. So we can write y into log x is equal to x minus y. Or this can also be written y log x plus y is equal to x. So let us differentiate here. Y into differentiation of log x is 1 upon x plus log x into differentiation of y is dy by dx plus again y is dy by dx is equal to differentiation of x is 1. So we can write y upon x plus log x plus 1 times of dy by dx is equal to 1, or we can write dy by dx times of 1 plus log x is equal to 1 minus y upon x, or we can write x minus y divided by x. dy by dx into dy by dx is equal to, we can write dy by dx is equal to x minus y upon x into 1 by 1 plus log x. And here we can write x minus y is equal to y log x. So here I can write here dy by dx is equal to x minus y is y log x divided by x into 1 plus log x. And also we can also write here y taken common, 1 plus log x is equal to x, or y upon x is equal to 1 by 1 plus log x. Let us substitute here so that we can write dy by dx is equal to log x into upon y upon x. This y upon x value is nothing but 1 upon log x, 1 plus log x. So 1 plus log x into 1 plus log x is 1 plus log x whole square. So where we can see this as option A. So option A is the answer. If f of x is equal to log root of tan x, then f dash of x at x is equal to pi by 4 is. So now differentiating with respect to x. So we have f dash of x is equal to differentiation of log x 1 upon root of tan x into again d by dx of root of tan x, that is 1 by root of tan x into differentiation of root x is, we know that d by dx of root x is equal to 1 by 2 root x. So we can write 1 by 2 root of tan x into again d by dx of tan x by using the chain rule. So 1 by 2 root of tan x into root of tan x is tan x into differentiation of tan is secant square x. Now at x is equal to, you can write at x is equal to pi by 4. So f dash of pi by 4 is equal to 1 by 2 times of tan pi by 4 into secant square pi by 4, which is equal to 1 by 2 into tan pi by 4 value is 1 and secant pi by 4 value is root 2. So root 2 whole square is 2. So 2 upon 2, which is equal to 1. So we can go with an option B. Option B is the answer. The value of integral minus pi to plus pi sin power 3x into cos power 3x dx. So let f of x is equal to sin power 3x into cos power 3x, and f of negative x is equal to sin power 3 of negative x into cos power 3 of negative x, which is minus sin power 3 x into cos power 3 x, because we know that sine of negative theta is equal to minus sine theta and cos of negative theta is equal to plus cos theta. So you're getting f of negative x is equal to minus f of x, so which implies that f is an odd function. And we have the property integral minus a2 plus a f of x dx is equal to 0 when f is odd function. So here minus pi to plus pi sin power 3x into cos power 3x, since this function is odd function, this is odd function, and so minus pi to plus pi, so we can say the answer is 0. So we can go with an option D. Find the order and degree of the differential equation 2 times of dy by dx whole power 3 plus 3 times of d square y by dx square whole to the power 4 plus d cube y by dx cube whole square is equal to y. So here we can say that the highest order here means the highest derivative order is d cube y by dx cube, where we can say this is third order, and the power of this highest order is 2. We can say the degree is 2. So we can say that the given differential equation is having highest order is 3 and the power of the highest order is 2. So 3 comma 2. Order is 3, degree is 2. First option. The integrating factor of the differential equation dy by dx plus y is equal to 1 plus y upon x. So here we can write on simplifying dy by dx plus y is equal to 1 upon x plus y upon x. And further simplifying dy by dx plus y minus y upon x is equal to 1 upon x. Or we can write dy by dx is equal to dy by dx plus 1 minus 1 upon x into y is equal to 1 upon x. So we can write dy by dx plus it is in the form of p of x into y is equal to q of x. So where p of x is equal to 1 minus 1 upon x. And we know that integrating factor for this equation is e to the power integral p of x dx. So integrating factor is equal to e to the power integral 1 minus 1 upon x dx, which is equal to e to the power integration of 1 dx is x minus e to the power of 1 upon x is nothing but log x. So we can write e to the power of x upon e to the power log x, and since we know that the property a to the power log m to the base a is equal to m, and here the base is e, so we can write here e to the power of x e power x upon x. So e power x upon x is the integrating factor for the given differential equation, which is option B. The value of beta for which two vectors 2i minus j plus 2k and 3i plus beta j plus k. So let us consider this is vector A and vector B. We need to find the value of beta for which these two vectors are perpendicular. So vector A is perpendicular to vector B, which implies their dot product is equal to 0. So let us find the dot product. A dot B is equal to 2 into 3, 6. So we can write 2 times of 3 and again plus minus 1 times of beta plus 2 times of 1, which is equal to 0. That is 6 minus beta plus 2 is equal to 0. 8 minus beta is equal to 0. So that is beta is equal to 8. So we can say that the value of beta is 8, which is option B. If mod of the sum of the two vectors is equal to 60 and mod of the difference of the two vectors a minus b is equal to 40 and mod b is equal to 46, mod of the vector b is equal to 46, then find the mod of vector a. So squaring on both sides, we can write mod a plus mod b whole square is equal to 60 square, and here mod A minus B whole square is equal to 40 square. So which implies we know that mod A square is equal to A dot A. So by applying the dot product here, A plus B dot A plus B, will get mod A square plus mod B square plus 2 times of A dot B is equal to 60 square is 3600. So we can write here 3600. At the same time, the other one we can write mod A square plus mod B square minus 2 times of A dot B is equal to 1600. Since we need to find mod A, so let us do addition. So we'll get 2 times of mod A square plus 2 times of mod B square, and 2 times A dot B minus 2 times A dot B gets cancelled, is equal to 3600 plus 1600 is 5200. Or also we can write mod A square plus mod B square is equal to 2600. And here mod B square can be taken as mod B square is equal to 46 into 46, which is 2116. So let us substitute here mod A square plus 2116 is equal to 2600, or mod A square is equal to 2600 minus 2116, which is equal to, we can say here, 484. So mod A square is equal to, which is 22 square, so that we can write mod A is equal to 22. So we can go with an option mod A is 22, option A. The area of triangle whose adjacent sides are given, vector A is equal to I cap plus 4j cap minus k cap, and vector B is equal to I cap plus j cap plus 2k cap. And we know that if A and B are at the adjacent sides, then area of triangle is equal to half mod of A cross B. So let us find the cross product. A cross B is equal to determinant of, we can write here I, j, k, and the components here 1, 4, minus 1 for vector A, and 1, 1, 2 for vector B. So we can write here I times of 4 2s are 8, minus of minus plus 1, minus j times of 1 into 2, 2 minus of minus plus 1, plus k times of 1 1s are 1 minus 4. So which is equal to 9 times I minus 3 times of j minus 3 times of k, and mod of A cross B is equal to, which is equal to area of triangle, we can write half into modulus of the vector is root of 9 square plus 3 square plus 3 square, that is minus 3 whole square is plus 3 square, and here minus 3 whole square is plus 3 square, which is equal to 1 by 2 times root of 81 plus 9 plus 9, 18. So which is 1 by 2 into root of 99, that is 1 by 2 into root 9 into 11, that is root of 9 into 11. So we can write 3 by 2 times of root 11. So 3 by 2 root 11 is the answer, which is option C. Find the value of k for which the lines x plus 3 upon minus 3 is equal to y minus 1 upon k is equal to z minus 5 upon 5, and another line x plus 1 upon 6 negative 6 is equal to y minus 2 upon 2 is equal to 5 minus z upon negative 10. So the second line equation can also be written as x plus 1 upon negative 6, y minus 2 upon 2 is equal to z minus 5 upon plus 10. Since the two lines are parallel, so we can say that the direction ratios are same. So here the direction ratios are, or the direction ratios are proportional, we can say here minus 3, k and 5, and here the direction ratios are minus 6, 2 and 10. So since they are parallel, we can say that minus 3 upon minus 6 must be equal to k upon 2 is equal to 5 upon 10, or we can write here 1 upon 2 is equal to k upon 2, or 1 upon 2. So the value of k is equal to 1. So the value of k must be equal to 1, which is option D. The corner points of the feasible region determined by the system of linear inequalities are 0, 0, 4, 0, 2, 4 and 0, 5. If the maximum value of z is equal to ax plus by, where a, b greater than 0 occurs at both 2, 4 and 4, 0, then. And since the corner points are given 0, 0, 4, 0 and 2, 4 and 0, 5, and in which it is mentioned that the maximum is occurring at both 2, 4 and 4, 0, 2, 4 and 4, 0, so that we can say that the maximum value, that is z is equal to ax plus by, will give the same value at 4, 0. Z is equal to a into 4 plus b into 0, which is 4a, and at 0, 2, 4, z is equal to, profit function will give z is equal to a times of 2 plus b times of 4, which is 2a plus 4b. Since both occurring at maximum value at these 2 points, so we can write 4a is equal to 2a plus 4b, or 4a minus 2a is equal to 4b, or we can write 2a is equal to 4b, or a is equal to 2b. So we can mention here a is equal to 2b, which is option A. The point which does not lie in the half plane 2x plus 3y minus 12 less than or equals to 0. So here we can say that the line 2x plus 3y minus 12 is equal to 0 is the equation. The half plane will be either upper half plane or lower half plane to this, and the point which satisfies can be this half plane, and which does not satisfy will be the other half plane. So we can consider 1, 2 point. Let us substitute the points 1, 2, whether they are satisfying or not. So 2 times of 1 plus 3 times of 2 minus 12, that is 2 plus 6 minus 12. 8 minus 12 is minus 4, which is less than or equals to 0 is satisfying. So 1, 2 is existing in this half plane, and option being 2, 1, let us substitute here 2 times of 2 plus 3 times of 1 minus 12, and here 4 plus 3 7, 7 minus 12 is minus 5 is less than or equals to 0. So we can say that this is also, this point is also satisfying. And coming to the option C, 2, 3, so 2 times of 2 plus 3 times of 3 minus 12 is less than or equals to 0, that is 4 plus 9 13 minus 12 is 1. 1 is less than or equals to 0 is false. So we can say that this point is not satisfying, not belonging to this half plane. So the point which does not lie in the half plane is C2, 3. 2, 3 is the option. And also let us check the option D. So option D will give minus 3, 2. So 2 into minus 3 plus 3 times of 2 minus 12, which is minus 6 plus 6 minus 12, which is minus 12 less than or equals to 0 is true. So this point is also satisfying the half plane. So the point which does not lie in the half plane is 2 comma 3. A speaks truth in 60% of the cases, while B speaks truth in 40% of the cases. In what percent of cases are they likely to contradict each other stating the same fact? So here A speaks truth 60%, that is 60 by 100. We can say 6 upon 10. Then A speaks false will be 1 minus 6 upon 10, which is 4 upon 10. Similarly for B, speaks truth is 40%, that is 40 by 100, that is 4 upon 10, and speaks false can be considered as, it is given 1 minus 4 upon 10, which is 6 upon 10. And according to the given condition, both are likely to contradict each other, which means if A says truth, B says false, or if B says truth, A says false. So here we can use A says truth is 6 upon 10, B says false is 6 upon 10, and A says false is 4 upon 10, and B says truth is 4 upon 10. So which is nothing but 36 plus 16 upon 100, that is 52 divided by 100, that is 52%. So 52% cases they likely to contradict each other stating the same fact. So which is option B. If a line makes an angle of alpha, beta, gamma with the positive direction of coordinate axis, then the value of sine square alpha plus sine square beta plus sine square gamma is. Since a line makes an angle alpha, beta, gamma with the positive direction of coordinate axis, so we can say that cos alpha, cos beta, and cos gamma are the direction cosines. They are the direction cosines of line, so that we have the relation cos square alpha plus cos square beta plus cos square gamma is equal to 1. Cos square alpha we can write it as 1 minus sine square alpha, and cos square beta we can write 1 minus sine square beta, and cos square gamma we can write 1 minus sine square gamma, which is equal to 1. So we can write 1 plus 1 plus 1, that is 3 minus of sine square alpha plus sine square beta plus sine square gamma is equal to 1, or we can write 3 minus 1 is equal to sine square alpha plus sine square beta plus sine square gamma. So we can write sine square alpha plus sine square beta plus sine square gamma is equal to 3 minus 1 is 2. So we can go with an option 2, which is B. Assertion and reasoning. Assertion is given a relation R is equal to A comma B such that mod of A minus B is smaller than 2, defined on a set A is equal to 1 comma 2 comma 3 comma 4 comma 5 is reflexive. So here we can write the reflexive definition. A relation R is said to be reflexive if for every element belongs to the set A comma A must belongs to the relation R. Then we can say that the relation is reflexive. So here for every A belongs to the set A minus A mod which is equal to 0 is always smaller than 2. So that we can consider this relation is R is reflexive. So we can say that the first assertion is true. Assertion is true. And coming to the reasoning, a relation R on the set A is said to be reflexive if A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R, which is a transitive condition, which is not reflexive. So we can say this is not the definition for the reflexive, and hence the reason is given is false. So assertion is true and reason is false. We can go with an option C. Assertion is given if f of x is equal to tan x minus x is always increases. Let us check this by doing differentiating. Differentiating the function f dash of x is equal to tan x differentiation is secant square x minus differentiation of x is 1. And we know that secant x belongs to minus infinity to minus 1 union 1 to infinity. So which implies that secant square x must be always greater than or equals to 1 to infinity. So secant square x minus 1 must be greater than or equals to 0. So we can say that, or else we can also mention here secant square x lies between plus 1 and infinity, and secant square x minus 1 lies between 0 and infinity. So we can say that secant square x minus 1 is always positive. So this is always greater than or equals to 0, and hence f dash of x is greater than 0 for every value of x, for every x defined in the domain of the function, and hence we can say that f is increasing. F is increasing always. And coming to the reason, any function y is equal to f of x is increasing if dy by dx is greater than or equals to 0, which is a fact. So the function is said to be increasing if differentiating is always greater than or equals to 0 for the value of x in the domain of the function. So we can consider that the assertion is true and reason is also true, and which is the reason for the assertion. So we can go with an option A. Both assertion and reason are true and R is the correct explanation of A.